Welcome to Lesson 78 of our interactive notes. Lesson 78, we're going to draw and identify parallel and perpendicular lines. Page 31 and 32. Okay, so our content objective for 4th grade G Geometry 1. I can identify and draw parallel and perpendicular lines. Language objective, I can use vocabulary related to geometry to describe parallel and perpendicular lines. Social objective, I can work with others to use models to help identify parallel and perpendicular lines. So parallel means that they are lines that are always the same distance apart and will never meet. So lines continue forever. That's what those arrows mean. And at no point will they ever touch. They're always going to be exactly the same distance apart. Perpendicular. Two lines that form right angles, which are 90 degrees, as they intersect. So here these two lines have formed right angles, so they would be perpendicular. They do cross, they intersect, but when they intersect, they make the special right angle. Okay, so here we're just going to look. Parallel lines, lines that never intersect and are always the same distance apart. Hint, two of the letters in the word parallel form parallel lines. Can you find them? Hopefully you found the two L's are parallel. So here we have two examples. Are these two lines parallel? Are they the same distance apart the whole way? Or also, as you picture them continuing forever, will they ever cross? If they will cross, then they are not parallel. If they are not the same distance apart the whole way, then they are not parallel. These two lines are the same distance apart. It's hard to see what this little guy is saying. It says, my lines are parallel. They will never intersect. That's what he's saying. Here, these lines are the same distance apart, and if I extended them out even forever, they would stay the same distance apart. They would never cross. So this is true. These two are parallel. These are not the same distance. These are the same distance. So now in these shapes, we want to identify any parallel lines. Well, here we have line CD and line AB are parallel. So line segment CD and line segment AB are parallel. Line segment CA, this one, is parallel to line segment DB. And that's it. So we have opposite sides are parallel. When we have two that are, we call this a parallelogram. All right, let's see here. We have GH is parallel to JI. So GH and JI. Remember capital letters, and we put that line segment on top to indicate that they're line segments. Let's see, FG is actually parallel to HI. If I extend those line segments out, they would never cross. And then the same thing for JK and HI. and this one. So I'm sorry, these cross. They cross here, they cross here. If I extend them out, they would cross these. If these extended out, they would cross or intersect. So since these two lines are intersecting with other lines, they're not parallel to anything. So these are the only ones that would be considered parallel. In this heart shape, we don't even have lines or line segments. We have a curve here. So it's not a line or a line segment. So that has no lines at all, so we can't have any parallel lines. So no parallel lines, because we don't have line segments or lines at all. Okay, now let's look at our perpendicular lines. And this guy here is saying my lines are perpendicular. They intersect to form a right angle. Two lines or line segments that intersect to form right angles. Intersecting lines are lines that meet at a common point, or they cross each other. There's a part. Even when it comes to streets, where they cross each other is called an intersection. At the intersection of Ramona Boulevard and Main Street, at the intersection of 7th Street and State Street, that's where they cross. So if we picture these as roads, that's where the roads cross. Now, to be perpendicular, not only do they intersect, they make right angles. So here we have right angles. So this would be true. These are perpendicular. Here it intersects or crosses, but we have two acute angles and two obtuse angles. We have no right angles, so this one is false. Okay, now in these shapes, we want to look for our right angles to see if we have any perpendicular lines. Well, all of these are actually acute angles. We have no right angles. So can we name perpendicular lines? Oh, there's none. All we have are intersecting lines. We only have intersecting line segments. They intersect, but they do not form the right angles, so they're not perpendicular. But here we have lots of perpendicular lines. We have lots of right angles inside of this one. So we have a few that we're going to end up listing. Lots of right angles on this shape. So we need some room to write all these. So you want to write kind of small. So NO is perpendicular to OD. NO and OD. OD is perpendicular to DE. DE is perpendicular to EF. EF is perpendicular to FG. Okay, FG is perpendicular to GH. GH is perpendicular to HI. Okay. My word "and" is taking up a lot of room, so I'm actually going to show you something that you'll use in high school, and that's the symbol for perpendicular. So HI is perpendicular to IJ. So HI, and the symbol for perpendicular looks like an upside down T, HI is perpendicular to IJ. Then IJ is perpendicular to JK. JK is perpendicular to KL. There's also a symbol for parallel, and it's two parallel lines instead of writing the word parallel. KL is perpendicular to LM. LM is perpendicular to MN. And finally, MN is perpendicular to NO, and we're back where we started. So this shape had lots of perpendicular lines, lots of right angles formed. And then in this shape right here, we don't have any lines. We only have circles and curves. Lines must be straight, line segments must be straight. So we have no lines or line segments. So that means we can't have perpendicular lines because we have no lines at all. So we have no perpendicular or intersecting lines. We have none that even cross. We have no lines at all. We only have curves. All right, so let's go ahead and continue with our 3-column notes, practicing identifying and drawing parallel and perpendicular lines.